Hey, welcome back. In this video, we will discuss about generators in Python. Okay, so what exactly is a generator function? So generators are basically the iterators. Okay, this is one type of the iterator. So generators are functions that can pause and resume their execution. This is very important. Okay, the normal function cannot do that, right? When a generator function is called, it returns a generator object, which is an iterator. Okay, all right. The code inside the function is not executed yet. It is only compiled. The function only executes when you iterate over the generator. Okay, generators allow you to iterate over data without storing the entire dataset in the memory. Okay. Instead of using the return, generators use the yield keyword. Okay, all right. So we have been talking about generators in this comment. So let's see the generator in action. First of all, let's see a function without the generator. So def count up to, and it will take the number. Okay, and let's declare a variable count equals to 1 while count is less than or equals to the number. Okay, what we can do something like this. So first of all, let's declare a list. So numbers list equals to an empty list. Okay, and here what we can do something like this. So numbers list dot append, okay, the count. All right, and then we can do count plus equals to 1. All right, and after everything is done, we can return the numbers list. Simple enough. So this is a simple function. It is not a generator function yet. Okay, it is using the simple return keyword. All right, so now if I just do print and then do count up to, let's do 5. Okay, and now if I run the program, as you can see, we are getting the list all together at once. Okay, 1 2 3 4 5. All right, so as you can see here, if I just go inside of this comment, okay, so yes, generators allow you to iterate over the data without storing the entire dataset in the memory. Okay, so basically what exactly is happening, this numbered list is getting stored inside of the memory altogether. Okay, so if we do not want to do that, then we can use the generator for that. Okay, so what I can do, I can just get rid of this one. Okay, all right, and I can just get rid of this one as well, and I can get rid of this line as well. And instead of returning something, we can yield the count. Okay, now if I just run the program right now, something interesting will happen. So as you can see, we are getting the generator object here. Okay, so we are not getting the full like data, we are getting the generator object. And when we are iterating over this generator object, then the code executes. So what do I mean by that? So if I just comment out this one and do a for loop for num in count up to 5. Okay, and here we can do print of num. All right, okay, as you can see here, we can iterate over this one, like the count up to 5, because this count up to 5 function is returning us the generator object. Okay, and we can iterate over the generator object. Why we can do that? We can do that because when a generator function is called, it returns the generator object, which is an iterator. Okay, so it acts like the iterator. Basically, it is the iterator. Okay, so if I now run the program, we are getting 1 2 3 4 5. Okay, so this is basically the generator function here. Okay, so unlike the return, which terminates the function, the yield keyword pauses and be called multiple times. Okay, so what exactly is happening under the hood? We are getting here, so count is equals to 1, that is good. And then while count is less than or equals to number, we are basically yielding. Okay, so yield count, so we are basically returning the count here, and then we are pausing. And in the next time, when the next method internally calls, we are getting to the next line, the count plus equals to 1, and then once again we are returning the count, and once again it pauses, and so on and so forth. I hope that makes sense. Okay, so here, as you can see, this is a simple generator function. Okay, all right. Also, what we can do here, we can use the next method as well. So what we can do something like this. So I will just comment out this function here. So now let's create a simple generator function. So that generate person. Okay, and here we can do yield something like John, then Jane, and then Sarah. Okay, all right. So this is our simple generator function. So now what we have to do something like this. So let's do person equals to generate person. Okay, or person generator, basically, because the generate person is returning the generator. And now if I just print, okay, all right, print the person generator, once again we will get the generator object. Okay, that is good. Now what we can do something like next, and then person generator, and we can do it multiple times. So let's not do this one. So if I just now run the program, as you can see, we are getting John, then Jane, then Sarah. Okay, all right. So this is how the generator works. And if I just do one more time, then we will get the error, and you can guess what exactly is the error. It will be the stop iteration error. Okay, all right. So John, Jane, and Sarah, and then we are getting the stop iteration error. Okay, awesome. So in this way, we can use the generator functions. Okay, so generators are simple functions which uses the yield keyword instead of the return keyword. And the speciality of the yield keyword is it can pause the function execution. And whenever we are basically calling the next with this generator object, we are getting to the next line, okay, inside of the function. All right, awesome. So here, as you can see, this is the generator in action. Okay, so now let's discuss about the yield keyword in a bit. So what exactly is the yield keyword? The yield keyword is what makes a function a generator. When yield is encountered, the function's state is saved, okay, and the value is returned. The next time the generator is called, the function continues from where it left off. Okay, so this is basically the yield keyword. So let's see how we can save some memory with the help of generators. Okay, so here what I can do, I can just comment out this one. Okay, all right, and here, as you can see, generators are memory efficient because they generate values on the fly instead of storing everything in memory. For large data sets, generators save the memory. Okay, so what we can do, we can create a function def large sequence. Okay, it will take the number. All right, and then for I in range of the number. All right, what we can do yield I. Okay, all right, and now what I can do, I can just do something like num. Okay, all right, So this is our simple generator function. Okay, so now let's do number generator equals to, or let's do not the number generator, sequence generator. Sequence generator equals to large sequence, and let's add 1 1 2 3 4 5 6. Okay, so let's do something like this. So 1 with 6 zeros. All right, and if I now save that and just do print the next, okay, next of sequence generator, so we can do something like this. Okay, let's do something like this. All right, so run the program. We are getting 0 1 2 3 4. Okay, quite simple. We are not storing this whole total number inside of the memory, but instead if I just do something like this, or if I just do something like this and do return, okay, return the number. All right, and here I can just print the sequence generator. Okay, so let's see what happens. If I just run the program, we are just getting 0 here. Why is that? Because we are inside of this one, right? So let me just think how we can like make sure we are printing everything here. Okay, so okay, all right, so what exactly is happening here? So what I'll do, I'll just get rid of this one. Okay, and large sequence of, let's do the same number. All right, so here run the program. We are still getting 0 because the loop is running only once. So what we can do, we can, instead of returning this one, we can do something like print the number. Okay, if I just do that, all right, and we don't have to print this one, we don't have to do this one, we will do something like this. If I just run the program right now, okay, as you can see, it is continuously printing. Okay, and it takes quite a while. All right, but instead of doing something like this, if we just do something like, instead of doing something like this, so we are not printing that, we will do just yield the number, and here now after this one, so what we can do, we can add a for loop. Basically it will return the generator. So for num in large sequence, okay, and here we can print the num. All right, so if I just do that and run the program, as you can see, it is running quite fast. Okay, so basically what exactly is happening, it is not that much visible while doing the same thing. So what we can do, let me just do something like this. So I will just comment out this one, okay, and do something like large sequence of, let's do 1 with 10 zeros. Okay, 1 1 2 3 4 5 6 7 8 9 10. All right, so this will be 10 zeros. All right, and here we will just print the num. Okay, if I just do that, I hope that will be a little bit more clear. Run the program. Okay, it is running, and it will take quite a while. Okay, it is continuously running, and my computer is kind of basically screaming right now. So as you can see, it is continuously running here. Okay, so I will just interrupt this one. All right, but if I just comment out this one and do something like this, comment out this one and do something like this, and now run the program, as you can see, this will be a lot faster. Okay, as you can see, we are saving the memory, and this, like, printing out all of the numbers is a lot faster. Why is that? Because we are using the generator function here. So I hope the difference is clear. with the generators. Okay, so yeah, this is basically it. So generators basically saves the memories when we are dealing with a large data set. Okay, awesome. So this is the generators in Python, and in the next video we will discuss about the generator expressions. Okay.